All right, everybody, welcome back. We are live with Mr. Lowe's Homeroom. Everybody say hi. All right, okay. And we are back with part 2 of our video because we ran out of time. What we talked about last time was probability, and now we're going to continue talking about probability. But right now we are looking at tree diagrams. And thank you. It says a penny and a dime are tossed at the same time. What is the probability of a tails on the penny and a heads on the dime? We're going to use a tree diagram, and I'll start with our first toss. So that'll be right here. If I throw both the penny and the dime at the same time, each penny has a probability of landing on a head or a tail. So it could be heads up or tails up. Okay? And then if I throw the penny and it lands on heads, when I throw the dime, it could also land on heads or tails. And if I throw the penny and it lands on tails, when I throw the dime, it can also land on heads or tails. So any one of those outcomes, if I throw the penny and it lands on heads, it can land on a head, where this first H is, let's do it in different colors. That way we can kind of talk about it. Boys and girls, I need you to get quiet, please. Thank you. So if our dime then is a head here, it could be heads on the penny, heads on the dime. If it's still a head on the penny, it could be a tail on the dime. Or it's going to end up being the other way around, where, let's make sure I got the colors right here. If it's tails first, here and here, it could also be a head here and a tail here. So the only outcomes are a head and a head and a tail and a head, and a tail and a tail. The question was, what is the probability of it landing penny on heads and a dime on heads? Oh, tails on the penny. Sorry. Can't read that. There we go. Tails on the penny and heads on the dime. Tails on the penny, it's going to be one of these two, and heads on the dime. Well, if there are 1, 2, 3, 4 possible outcomes, it is a 1 in 4 chances. 1 in 4 probability of landing on that combination. Now, you can also solve this problem using just a little bit of math, and we call that little bit of math the fundamental counting principle. The fundamental counting principle basically says to find the total number of outcomes, I take the total possibilities of outcomes from the penny, which is a head and a tail, that's 2, and the dime, which is a head and a tail, that's 2, and I multiply those two. 2 times 2 equals 4. So there are 4 possibilities, but there is only one of those possibilities being the answer. Thank you. And we'll try one more as a decent example. Let's see, I gotta change colors here. Okay, Kyle wants to buy a portable color TV. The store has 2 different models. One model has a 13-inch screen TV and the other a 19-inch screen TV. Each model is available in 3 cabinet colors: black, brown, and white. I know. You're all saying, but Mr. Lowe, they're not flat screen TVs. Well, this is kind of the television that I grew up with, so we're going my days. Yeah, I know, it is pretty gross. Sorry about that. So anyway, your choices are either a 13-inch screen TV or a 19-inch. So I have 2 choices there. So if I were to make my tree diagram, I'm putting my first choice like this. I have 2 possibilities, either the 19 or the 13-inch screen TV. But each of these models, the 19 and the 13, come in black, brown, or white. So if I choose the 19-inch screen TV, it can be one of 3 colors: black, brown, or white. And the same thing, I am there. Hello, Mrs. Hannah. I am live. Would you like to say hi to the kids? Okay, you're being videoed. She says hi. Okay, go ahead. What can I help you with? And who are you looking for? Ooh. Have not seen him. Alright. Alrighty. Bye. Okay. That was Mrs. Hannah. Any hooch, we have a 13-inch screen TV that can also be one of three choices: black, brown, or white. So, use the tree diagram to find all the possible combinations. Well, it's two choices in here. We're going to use the counting principle, and each one of those two choices has three possibilities, and 2 times 3 equals 6, and that tells us what our final possibilities can be. 6 different choices. Alright, so tomorrow, guys, when you come into class, you're going to be working on a couple of different things, using tree diagrams, using prime factorization, and a little bit of probability. Have a good night. Everybody say goodbye.